Aquaponic systems use plants to take up dissolved nutrients produced from fish waste, but mechanical filtration, biological filtration, circulation, and protection from clogged plumbing remain essential. University extension sources also document water rooting or water culture for pothos, spider plantlets, Syngonium, and lucky bamboo. While controlled hydroponic research supports the adaptation of spathiphyllum under suitable root zone conditions, your aquarium filter may be one of the most valuable areas in your entire setup. Yet in most tanks, it does absolutely nothing. Water enters the filter, passes through a pad and some biological media, then returns to the aquarium, while the entire space above it remains empty. Meanwhile, many aquarium owners keep buying additional media, replacing cartridges, adding clarifiers, reducing feeding, and cleaning the glass, only to watch cloudy water or algae slowly return. There is another way to use that space. With the correct plant and a safe support system, part of your filter can become a small, soil-free growing area where living roots remain in constant contact with nutrient-rich aquarium water. But before putting any plant into a filter, check 3 things. Make sure the roots cannot reach the impeller. Make sure they cannot block the overflow. And make sure the plant's crown and leaves will remain above the highest possible water level, including when the pump is switched off. Miss any one of those checks, and a healthy plant can eventually weaken the filter instead of helping it. In this video, you'll see 5 plants that can work in hang-on back filters, rear filtration chambers, overflows, and sumps. How to choose the correct one for your system, and how to stop the roots from turning into a hidden maintenance problem. The easiest plant on this list is also the plant most likely to send roots directly toward your pump if you leave it unchecked. To understand why this works, look at what the filter is already doing. Water from the aquarium continually carries dissolved waste into the filter. Beneficial bacteria process nitrogenous waste into forms that plants can use, including nitrate. When roots are positioned in that moving water, they receive a more consistent supply of water and dissolved nutrients than a plant sitting in a small, stagnant container. The leaves remain in the open air, where carbon dioxide is much more available than it is underwater, and where they can receive light without shading the aquarium. This gives fast-growing terrestrial plants an important advantage over many slow-growing submerged plants. Their roots can also provide additional surfaces where microorganisms form biofilms. However, this does not mean the plant replaces your biological media. It also does not replace the filter pad that catches suspended particles. The plant is an additional layer in the system. Mechanical media catches physical debris. Biological media supports the nitrogen cycle, and the plant uses some of the dissolved nutrients that remain in the water. Remove the original filtration just to make room for roots, and you may create dirtier water, weaker flow, and less biological stability. Number 5 is lucky bamboo. Despite the name, lucky bamboo is not a true bamboo. It is a dracaena with upright canes that can create a clean, vertical shape behind an aquarium. This makes it especially useful when you want the plant filter to look intentional, instead of appearing like a random vine hanging from the tank. Lucky bamboo works best in a large rear filtration chamber, an overflow compartment, or a sump, where the roots can sit in gently moving water without being pushed against a pump intake. Keep the root system in the water while the leafy growth remains above it. Do not submerge the entire cane, and never place the leaves underwater. Although lucky bamboo is often displayed with part of its lower stem standing in water, deeper placement is not automatically better. The plant still needs oxygen around the root zone, support around the stem, and enough open space to avoid constant rubbing against a filter lid. Use a rigid holder-slotted basket or adjustable plant clip to keep the cane upright. Position it far enough from the return pump that new roots cannot grow directly into the intake. Lucky bamboo becomes a poor choice for a tiny hang-on back filter because the cane is tall, the plant is heavier than a cutting, and the filter lid may no longer close correctly. It also usually grows more slowly than Pothos, so it should be selected for shape and presentation, rather than for the fastest possible nutrient uptake. If you have a display tank with a wide rear chamber, however, 1 or 2 upright canes can hide equipment and create a strong transition between the aquarium and the room above it. Number 4 is the spider plant. A mature spider plant is usually too large and heavy for a small filter, but its young plantlets are almost perfectly shaped for this job. These small offshoots already have a compact center and may begin forming short roots before they are removed from the parent plant. That allows you to start with a small plant instead of forcing a large, soil-grown root ball into the filter. The leaves arch downward and soften the appearance of a hard plastic filter, making the plant useful in open aquariums where the filtration equipment is visible. The critical area on a spider plant is the crown, the compact center where the leaves and roots meet. The roots can enter the water, but the crown should remain above the waterline. If the crown is continuously submerged or blasted by the filter return, it may begin to soften and rot. Place the plantlet in a small slotted basket and allow only the young roots to reach the moving water. Keep the basket away from the overflow lip so that the leaves cannot fall into the return path. Before installation, remove every piece of potting mix or fertilizer granule from the roots. Soil trapped around the crown can break apart inside the filter, hold decomposing material, and make it difficult to see whether the roots are healthy. Spider plantlets are useful because they are easy to replace and easy to remove. If one fails to adapt, you have not lost a large established plant or filled the entire filter with roots. The limitation is that young plantlets have small root systems, so their effect will initially be modest. They also need suitable light above the aquarium. A plant positioned behind a tank may receive far less light than the plants inside it, even when the aquarium light appears bright from the front. Number 3 is Syngonium, commonly called the arrowhead plant. Syngonium is one of the strongest choices when appearance matters almost as much as function. Its arrow-shaped leaves create a tropical look, and its flexible stems can be directed along a shelf trellis or support behind the aquarium. It can be started from a small rooted plant or from a healthy cutting that contains at least one node. The node or established roots can sit in a slotted holder while the main stem and every leaf remain outside the filter. Syngonium usually works better in a wider hang-on-back filter, a rear chamber, or a sump, than in a very narrow filter cartridge compartment. Its roots can become dense, and that density is both an advantage and a warning. A larger root system creates more contact with the flowing water, but it can also trap detritus, collect pieces of decaying leaves, and slowly occupy the space needed for the original filter media. When the roots begin forming a solid mat, do not pull the entire plant out and tear away every root in one aggressive cleaning. That can release trapped debris into the filter and remove a large portion of the plant's functioning root system at the same time. Instead, lift the basket carefully, rinse loose debris in removed aquarium water, and trim selected roots while leaving the healthiest roots intact. Syngonium also becomes heavier as the vine grows. A loose cutting that looked secure during the first week may eventually tip forward or fall into the aquarium. Support the stem independently instead of asking the filter lid to hold the entire weight of the plant. With controlled roots and a proper support, Syngonium can turn an exposed filter into a planted feature rather than something that needs to be hidden. Number 2 is the peace lily. This is the plant for larger systems, not the plant to force into a tiny hang-on-back filter. A small peace lily can create an elegant focal point above a rear filtration chamber or sump, but its weight, crown structure, and larger root mass require more space. It is best used in an open aquarium, a large overflow, a rear sump, or a dedicated plant chamber where the root system can receive moving, oxygenated water. Begin with a small plant rather than a mature specimen. Remove it from the pot and gently wash away all soil until the individual roots are visible. Cut away roots that are already black, hollow, or soft. Healthy roots should feel firm, even when their color varies. Place the remaining root system inside a hydroponic basket or rigid support, and keep the crown above the waterline. The crown must not become trapped beneath a lid or submerged whenever the filter chamber fills. The difficult stage is the transition from soil to water. A peace lily may lose some older roots or develop yellow leaves while it adapts. That does not automatically mean the experiment has failed, but dead roots should not be left to decompose inside the filter. Check the root mass regularly during the first few weeks and remove only material that is clearly soft or decaying. Avoid placing the plant where water constantly splashes into the center of the leaves. Peace lilies tolerate lower indoor light than many decorative plants, but low light tolerance does not mean that a completely dark filter corner will support strong growth. Provide bright indirect light above the tank or a small dedicated plant light. A peace lily can look more refined than a long pothos vine, but it is less forgiving. It can lean crowd the filter or experience more transplant stress. For that reason, it belongs in a system where you can easily inspect the roots and remove the basket without dismantling the filter. Number 1 is Pothos. For most aquarium owners, this is the easiest plant to begin with because a small cutting takes up very little room, roots readily, and can be removed or repositioned without disturbing the entire filtration system. Pothos works in many hang-on-back filters, rear filtration chambers, overflow sections, and sumps. It can trail along the wall, climb a support, or grow across a shelf above the aquarium. Start with 1 or 2 healthy cuttings. Each cutting needs at least 1 node, which is the point on the stem where roots and new growth can develop. Remove any leaf that would otherwise sit inside the filter. Place the node or existing roots in a small slotted basket, but keep the leaves and most of the stem above the water. Secure the vine so that fish movement maintenance or the weight of new growth cannot pull it into the aquarium. In a hang-on-back filter position, the basket in an area with reliable water movement, but keep a clear gap around the impeller housing and return channel. Do not push a loose bundle of roots directly into the same compartment as the motor. In a sump, use a basket or physical divider to prevent roots from crossing into the return pump chamber. Always leave enough room to remove and clean the original filter media beneath the plant. The biggest danger with Pothos is also the reason it works so well. It grows. A small cutting with several short roots can eventually produce a thick network that wraps around biological media, enters pump openings, catches debris, and slows the flow through the filter. Because the change happens gradually, the aquarium may appear normal until the filter begins returning less water. Never judge the filter only by the sound of the motor. Look at the actual return flow every week. When Pothos roots become too long, trim them in stages. Remove a portion of the longest roots. Leave the firm, healthy roots and inspect the pump guard. Do not grab the entire root mass and pull it through the filter media. Roots that have grown through ceramic media or coarse sponge should be separated slowly while the filter is removed from the aquarium. Pothos is the most flexible choice on this list, but it still requires controlled growth. The type of filter determines which plant will work safely. A small hang-on-back filter usually has room for 1 Pothos cutting or 1 young spider plant. A larger hang-on-back filter may support Pothos or a small Syngonium, provided the overflow and impeller remain completely clear. Rear filtration chambers offer more flexibility because the roots can be hidden and separated from the pump using different compartments. A sump is the most adaptable option because it provides space for larger baskets, stronger supports, and separate plant lighting. It also makes root inspection easier. A sealed canister filter is different. Do not place a houseplant inside the body of a closed canister. The leaves cannot remain in open air. There is no useful light, and the filter is designed to operate as a sealed pressure system. A plant may be grown in a separate open chamber connected to the return line, but it should not be pushed into the canister itself. A sponge filter also has no safe plant chamber. You can suspend roots near its upward water movement, but that is growing a plant above the aquarium, not growing one inside the filter. To build a safe plant filter, begin with one small plant. A large root mass gives you no time to observe how the filter responds. Clean the roots thoroughly and remove soil, fertilizer pellets, damaged tissue, and loose organic material. Use a rigid clip net cup or slotted basket rather than allowing the plant to float freely inside the filter. The holder should support the plant without squeezing the stem or crown. Next, preserve the original water path. Water must still enter the filter, pass through mechanical media, move across biological media, and return to the aquarium without being forced around a wall of roots. Protect the impeller or return pump with a removable guard that can be inspected and cleaned. Do not use a fine screen that clogs more quickly than the roots would. The guard must stop larger roots while still allowing strong water flow. Then provide light for the leaves. Do not automatically increase the intensity of the aquarium light because that may create more algae inside the tank without significantly helping a plant positioned behind the filter. Direct a separate low-power plant light toward the leaves when necessary. Make sure the light and electrical connections are protected from splashing water. Before considering the setup complete, turn the pump off. Watch how the water level changes inside the rear chamber or sump. A system that looks safe while running may rise several inches when the pump stops submerging a plant crown that was previously dry. Restart the system and confirm that the roots do not shift toward the intake. This power-off test is one of the most commonly skipped steps, and it can reveal a problem before an outage turns it into root rot or a flooded filter chamber. So why might the aquarium remain clear for longer? A healthy emergent plant uses part of the dissolved nutrient supply that would otherwise remain in the water. Continuous circulation repeatedly brings new water into contact with the roots. The plant can therefore support a more stable nutrient processing system and may reduce some of the conditions that allow algae to grow aggressively. The roots also create additional surfaces for microbial growth. But plants cannot capture every form of dirt. A root system does not replace a filter pad when the water contains suspended waste. It does not fix a bacterial bloom immediately. It cannot compensate for excessive feeding, severe overstocking, rotting animals, or a filter that is too small for the aquarium. Green water algae may remain suspended even when nitrate is moderate, and fine debris may continue circulating until mechanical filtration catches it. The plant helps manage dissolved nutrients. It is not a substitute for removing physical waste. There is another trade-off that many planted tank owners miss. A large, fast-growing Pothos or Syngonium can compete with slow underwater plants for available nitrogen. If the houseplant grows rapidly while submerged aquarium plants become pale and nitrate repeatedly tests near zero, adding more houseplants may make the imbalance worse. The solution is not always to remove the plant entirely. You may only need to reduce the root mass, remove one cutting, improve feeding consistency, or adjust fertilization for the submerged plants. Measure the water instead of assuming that more roots are always better. 6 mistakes cause most plant filter failures. The first is allowing the roots to block the overflow. This can reduce flow or force water to escape through an unintended path. The second is allowing roots to enter the impeller or return pump. The motor may continue making noise even when the actual water movement has nearly stopped. The third is removing filter media to create more space. Keep the mechanical and biological functions the aquarium already depends on. The fourth mistake is adding several plants at once. If the flow decreases, roots begin decaying, or the aquarium plants become nutrient deficient, you will not know which change caused it. The fifth mistake is providing insufficient light above the tank. Roots sitting in nutrient-rich water cannot compensate for leaves receiving almost no usable light. The sixth is checking the plant only while the pump is operating. Power outages and maintenance shutdowns can change the chamber's water level and submerge parts of the plant that were supposed to remain dry. Maintenance can remain simple. Every week, look at the filter's return flow. Inspect the area around the pump guard. remove fallen leaves, and smell any roots that appear soft or discolored. Healthy aquatic-adapted roots should not smell strongly rotten. Wipe loose waste from the plant holder and make sure the stem has not shifted. Every 2 to 4 weeks, inspect the root length and trim only the roots that are entering unsafe areas or creating an excessively dense mat. Clean the pump guard and check the mechanical media underneath the plant. Redirect vines before they become heavy enough to pull the holder sideways. Test nitrate under similar conditions each time, preferably before a scheduled water change, so you can compare trends rather than isolated numbers. Do not trim the entire root system during the same maintenance session. Roots are not only anchors, they are the plant's active connection to water, oxygen, and nutrients. Removing nearly all of them can shock the plant and produce dying tissue inside the filter. Gradual pruning is safer and makes it easier to maintain stable flow. For a small hang-on back filter, begin with 1 Pothos cutting or 1 rooted spider plantlet. For a larger hang-on back filter, Pothos and a small Syngonium are usually the most manageable choices. For a rear chamber, Pothos, Syngonium, or Lucky Bamboo can work when their roots are separated from the pump compartment. For a sump, a small peace lily Pothos, Syngonium, or supported Lucky Bamboo can be used, but each plant should have a defined root zone. A tank with a tightly closed lid may require a modified opening or a separate external planter. Never crush the stem between the lid and filter body. The best plant filter is not the one with the largest mass of roots. It is the one that preserves strong water flow, keeps the pump protected, allows normal filter maintenance, and produces steady, healthy growth above the aquarium. Lucky Bamboo gives height. Spider plantlets fit small spaces. Syngonium creates a tropical shape and a dense root system. Peace lilies suit larger display systems. Pothos remains the easiest and most flexible starting point. Begin with 1 cutting. Protect the pump. Keep every leaf above water. And observe the filter before adding anything else. When the system is designed correctly, the empty area above your filtration can become a useful living extension of the aquarium, rather than another piece of equipment to hide. If you want an aquarium that becomes more stable and easier to maintain without depending on exaggerated shortcuts, subscribe for the next practical planted tank guide. And remember, if the water still becomes cloudy while the plant is growing well, the problem may not be the number of roots. It may be the way the filter itself is being cleaned.